Good morning, students. Last time we had done with the sums of all the union and intersection type sums, and they are over. Now we continue with the remaining. First we have to do one concept, relation between number of elements in A union B and number of elements in A intersection B. Let us see what is the relation with our example. Set A consists of the elements 1, 2, 3. And set B consists of the element 3, 4, 5. How many elements are there in A? We have seen this symbol last time in the start of the lesson. I had given you. This means number and this means set A. Number of elements in set A, how many? 3. Number of elements in set B, how many? Again 3. Now let us find A union B. A union B. Join this up. Union means joining. Common only one. So which is a common element? 3 is common. That we will be writing only once. So A union B is how much? 1, 2, 3, 4, 5. How many elements are there in A union B? Number of elements in A union B. How many elements? 5. Now let us find the set A intersection B. Last time we had seen. What do we mean by intersection? The common elements. Which elements are common in A and B? 3. So we have 3. Number of elements in A intersection B is equal to 1. How many elements are there in A intersection B? 1. Okay. Now let us find the relation between these. Let this be 1. This be 2. All the number of elements I am putting numbers to it. 3 and this is 4. Now we have to find a relation between A union B and A intersection B. Now from A union B, A intersection B, A and B, the biggest number is 5. Okay. So A union B is 5. Let that be that way only. Now let us take the elements, number of elements in A plus number of elements in B minus number of elements in A intersection B. How much do we get? Let's see. How many elements are there in A? 3. How many elements are there in B? Again 3. Minus. How many elements are there in A intersection B? 1. How much do you get? 3 plus 3, 6 minus 1? 5. So let this be number 5. From 3 and 5, we are getting an important formula. I have derived the formula for you. The derivation is not important. The formula is important. So, you can write from 3 and 5. The important formula is number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. Because the right hand side, number of elements in A plus number of elements in B minus number of elements in intersection B also gives you 5, and number of elements in A union B is also 5. So you have to write down this formula in your notebook and study it by heart. Okay? No need of writing this. This is just for understanding. Number of, what is the formula? Let us repeat. Number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. Study this formula by heart. Now we are going to do sums based on this formula. Only write the formula for this. Okay, and study that formula by heart. Write it in your notebook and study it by heart. Now let us do the sums based on that formula. Take out practice set 1.4, the first sum. Practice set 1.4, sum number 1. How much is number of elements in A given? I am writing down the question here. Number of elements in A is 15. Number of elements in A union B is 29. Number of elements in A intersection B is how much? 7. These three things are given and you have to find number of elements in B. Okay, what is the relation between all this? You know the formula? Write down the formula first. Number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. Substitute it. A union B 29, A 15, B we do not know, so keep it B only, number of elements in B, minus number of elements in A intersection B. How much is A intersection B? 7. 29 is equal to 15 minus 7 is how much? 8. 8 plus number of elements in B. Now bring this side, 29 minus 8. When you bring this side, 8 becomes minus 8 is equal to number of elements in B. Therefore, number of elements in B is 21. Have you all understood this sum? Okay. Now the same type of sum is there, problem set 1, fifth one. Please write this down in your notebook. Now problem set 1, the fifth sum is the same. Only thing A intersection B is asked here. We will solve that also. Okay. So let us go to the problem set. So the next sum which is there is problem set 1. Fifth sum, page 17. Sum number 5. Okay, let us list what is given here. Number of elements in A is 20. Number of elements in B is 28. Number of elements in A union B is equal to 36. And you have to find number of elements in A intersection B. Okay, what is the formula which connects all of this? Write down the formula first. Number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements A intersection B. Now substitute. A union B is how much? 36. A number of elements in A 20. Number of elements in B 28 minus number of elements in A intersection B. Let us bring minus number of elements A intersection B over this side. So it becomes plus. And whatever is there, those numbers write down 20 plus 28 and 36 that side becomes minus 36. So number of elements in A intersection B will be 48 minus 36. How much is that? 12. Okay. Copy this sum also in your notebook. And on page 18, the same type of sum is there on page 18. That is for homework. Page 18, sum number, last sum, 11. Sum number 11 for homework. The same sum based on this number. Okay. Now come back to practice set 1.4. Now the sum number 2, 3, 4. These word problems are omitted. So write down omitted there 2, 3 and 4. Now we'll do sum number 5. Observe the given Venn diagram and write the following sets. Let me draw the Venn diagram here. This is A, this is B, and this is the universal set. A, B. Now what are the elements? X, Y, Z. And you can see in this overlap part A and B, which are the numbers M and N. And in B we have P, R, Q. And outside we have X and T. Sorry, not X. S and T. Okay. So we have drawn the figure. Now let us observe this Venn diagram and answer the following. This is with sum number 5. As I told you, second, third and fourth sums are omitted. So write down omit. You don't have to do it. Now sum number 5. The first one, A. Come on, look at the Venn diagram and tell me what is there in A. Which is the A? Set A is this whole circle. What is contained in set A? Come on, tell me which elements? X, Y, Z, M, N. This full circle is A. X, Y, Z, M, N. So you can write X, Y, Z, M, N. Next. B. Okay, now it is easy for you. You can pick out what is B. Which is B? This circle. So which are the elements in B? M and N comes in B also. M, N, P, R, Q. You can see in this circle whichever letters are there that I have written elements as B. Next, third one. A union B. What will come in A union B? This entire thing. This is A and this is B. So all the elements of A, all the elements of B common ones. So X, Y, Z, M, N. This is A ka elements. But M, N comes in B also, but you have to write in a set, you write, don't repeat the elements. So M, N is there here and the remaining elements P, R, Q. Fourth. Universal set. Okay, now tell me universal set, all the elements. First you write A's elements, B's elements. Now Mn repeated. We don't have to repeat. We can, it's already written here. P, R, Q. And outside this A and B, there are two elements, S and T. S and T. Fifth one is A complement. Now last time we had done what is A complement. What is A complement? Means not there in A but there in the universal set. So not there in A. This is our A. So don't take the A's element. Remaining elements you can take. So X, Y, Z, M, N will not come. So what will come? P, R, Q, S and T. Whatever is outside A, that comes. Okay, so next is B complement. I'll do it here. So same like A complement. B complement means not there in B but there in the universal set. So this B ka you don't write. Remaining you write. What is remaining? X, Y, Z, S, T. The last one, A union B complement. A union B complement. What is the meaning of A union B complement? Whatever is there in A union B, you should not write. This shaded part is there in A union B. So A union B complement means not there in A union B but there in the universal set.
1 minute.
So S comma T. A union B complement is not there in A union B but there in the universal set. So this A union B, it is not there. So what are the remaining elements? S comma T. Okay, so we have completed this sum. Please copy it in your, along with the diagram, you have to copy it in your notebook. Now the same type of sum is there in problem set. So that is for homework. Problem set 1. Page 18. Sum number 10. This is for homework. Same type of sum. Reading the diagram. Venn diagram. Okay. Now we go to problem set 1. Now we do it serially. We'll continue one after the other. Problem set 1. Now we are doing problem set 1. One after the other we'll do. Already the first sum I had done that day, union intersection sum it is, that is why. Now I am going to do the second sum. P is equal to x such that x is a odd natural number. One less than x less than equal to 5. How to write this set in roster form? Okay. So roster form means listing method. Each and every element gets its important. Okay. Which is the odd natural number which is between 1 and 5. Okay. Between 1 and 5, which are the numbers which will come? Let us write in the working column 1 and 5. Here there is no equal to sign, so 1 will not come. 2 will come, 3 will come, 4 will come, and 5 is also included because equal to sign. 2, 3, 4, 5. Now from this, x is a odd natural number. Which are the odd natural numbers from this? Yes, correct. 3 and 5. So which is the alternative here? 3 and 5? The D, option D. So second, we can write option D. Third, now I am going to do the third sum. P is equal to 1, 2 up to 10. What type of set P is? Is it they have given the options a null set? Is it null set? No, it's not an empty set. Is it infinite set? No, it is getting over at 10. There are 10 elements. We can count the number of elements in this. So it's not an infinite set. Is it a finite set? Yes. Because number of elements in P is 10. Therefore, P is a finite set. Whenever you can count the number of elements in a set, it's a finite set. So, which option number? Third, which option it is? Finite set is C. Option C. Okay. Now sum number 4 I had already done. Union sum it is. Fifth one also I had done again. So now we go to the sixth sum. Sixth MCQ. Which of the following sets are empty set? Set of intersecting points of parallel lines. Okay. The first one is set of intersecting points of parallel line. Does the parallel line intersect? No. So it's an empty set. So which of the following set are empty set? This one is empty set. The first one only is empty. So we don't have to check for the second and third one only. So is option number 6, option number A. 6th answer is option number A. This is an empty set because it does not intersect. Now question number 2. Which of the following collection is a set? Question number 2, the first one. Now they have given us colors of the rainbow. Is it a set? Yes, we can definitely say which are the colors of the rainbow. Violet, indigo, blue, green, yellow, orange. Set. Whenever you can say the members of the set, it is a well-defined set. Second is tall trees in the school campus. No, we cannot say. Tall trees. We cannot say which are the tall trees. Rich people in the village. No. That also is not a proper set. Easy examples in the book. No, that also cannot be a set because for one it might be easy, the other might be difficult. So which of the following is a set? The first one. Question number 2, 1. The answer is A. Colors of the rainbow. The question number 2, second one was already done. Now third one. P is equal to X such that X is a letter of the word Indian, and which one of the following is set P in list form? So let me write the question first. X is that? X is a letter of the word Indian. Okay. Now let us list the set. Okay. P is equal to. First underline the common words. I, common letters. N, N. Then D is there only once, A is also only one. So I and N are repeated. So repeated ones I am writing first I, N, then D, and then what is remaining? E. So which one is that option? B. So question number 3, option B shows INDA. Now fourth one was already done. Now question number 3 and 4 is again omit. Question number 3, omit. Question number 4 also omit. We are not doing such type sums. Question number 5 I have already done when we were doing number of elements A and B, and also question number 6 is omit. Just mark the omitted sums. Question number 7 I had already done last time, so that remains question number 8 to be done. Write the subset relation of the following sets. So, have you noted down the omitted sums? Question number 8. Write the subset relation for the following set. X is set of all quadrilaterals. Y is set of all rhombus. Rhombuses. S is set of all squares. T is set of all parallelograms. V is set of all rectangles. Over. Okay, now here little bit geometry knowledge is needed. We have to find out which is fully contained inside which set. Subset relations you have to set. Now you can see all rhombus, square, parallelogram, rectangles are all quadrilaterals. So we can say Y is a subset of X, S is a subset of X, T is a subset of X, and V is a subset of X. Okay, is this clear? Because all of them are quadrilateral. So each one is a subset. Y, S, V, T are all subset of X. Now next, square is a rhombus. All rhombus is not a square, but a square is a rhombus because square has all sides congruent. A quadrilateral with all sides congruent is a rhombus. So you can say S is a subset of Y. Same way, all rectangles are parallelograms. Parallelogram is not a rectangle, but a rectangle is a parallelogram, square is a parallelogram. So we get V subset of T and S subset of T, Y subset of T, because all are rhombus, square, rectangles, all are parallelograms. Any quadrilateral with opposite side parallel is a parallelogram. Now which other is remaining? Y is a subset of T, V is a subset of T, S is a subset of T over. Then S, so one more is remaining. Square is a square. All squares are rectangles. All rectangles cannot be squares, but all squares are rectangle because square ka opposite side is congruent. So S is a subset of V. We can write. Then I think all over. Yes, all over. Understood? So we have finished this. Ninth one was already done. 10th one was homework and 11th one was homework. So we have completed with the problem set. Now once again I will write down the omitted sums here so that it is clear. Okay. Whenever you want to write something, pause the video and write. Write down all the sums. Huh? Now I'll end with after writing down all the omitted sums of this chapter. Spelling of omitted is double T. From practice set 1.4, I am again telling which are the omitted sums. 2, 3 and 4. And from problem set 1, sum number 3, 4 and 6 are omitted. Okay, so with that we have come to an end of the chapter sets. Please write down whatever sums were done on the board and whatever is asked for homework should be done in the notebook. Thank you, students.